system. EFS we have seen an elastic file system. This is managed by a network file system. So elastic file system, what are the benefits over the block storage that we have studied already? But the first advantage and the difference between the elastic file system and the block storage is that EFS can be accessed through the multiple availability zone. So that means if we are going to create one EFS file and it is going to be protected within the security group, that particular file can be accessed by the different instances which are created in the different availability zones. That's a major point, and this is what we were trying to execute in the yesterday's class. Along with that, it is going to be much more expensive than that of the block storage. It is 3 times more expensive, okay, which is highly scalable, highly available. So this is what the benefits of EFS file systems are going to be. So let me share the screen and let's continue with that. Okay, so this is what we have seen: multiple instances in the multiple availability zone, and EFS file system is being created, and we are going to protect it using one of the security group. So this we have throughput, performance, availability, durability. These are the few concepts that we have studied. Infrequent access हमने also पढ़ा था. We have said this as well. Infrequent access, if you're not going to use this file for a much longer time, then you can store it into the EFS IA, but it is going to be protected by the life cycle policy. This is also we have seen. Okay, after how much time you want the EFS files move from standard point to the IA. This is much cheaper, 90% cheaper. Okay, so this we have studied already. EBS and the EFS, these are differences being given. Okay, so let's try to move back our management console and execute the same point that we were doing, management. And so let's try today if we are able to do it. Okay, but do you have an idea what we are trying to do? But what we are trying to execute? कोई idea है what we are trying to do now? What we were doing in the yesterday session? Can anyone tell me? Your presence of mind. But what we were trying to do yesterday?
सर कल हम फाइल सिस्टम क्रिएट किए थे और उसके बाद हमने 2 इंस्टेंस रन कराकर हम वो नेटवर्क ग्रुप को सिक्योरिटी देख रहे थे कि वो जो इनबाउंड रोल में है वो 0.0 की जगह कहीं और से आए, वो एक खास एड्रेस है जो कि नहीं आ रहा था कल.
हाँ हाँ, तो बेटा हम लोग करने के वाले हैं. उसके बाद हमारा पर्पस क्या है? व्हाट वी आर एक्चुअली ट्राइंग टू डू. हम क्यों कर रहे हैं ये चीज?
सर इलास्टिक फाइल जो स्टोरेज है उसका सिक्योरिटी चेक करने के लिए.
नहीं बेटा, मैं आपको बता रहा हूँ व्हाट वी आर ट्राइंग टू डू इज, let's revise what I'm trying to do right now that we were doing in the previous class. But this is what we are trying to do. Now we'll start with step number 1 will be we'll create EFS file system. ठीक है, step number 1 what I'll be doing, we'll create EFS file system. Step number 1. Step number 2 will be we'll try to create the security group. ठीक है, step number 3 will be create multiple instances. Okay, and these instances must be available in a different availability zone. Okay, so up to this point we have done yesterday's class. We will create the EFS file system, we'll create a separate security group, we'll try to create the multiple instances that are present into the different availability zone. After that what we need to do is that portion is still left. I'll try to open one of the instance in the different availability zone, another instance in the different availability zone. Okay, so from one availability zone I'll try to create a file. I'll try to create a file and I'll try to store it into EFS file system. Now when that file is stored in this EFS file system, beta from second availability zone I will not create that file. जो भी फाइल मैं यहाँ पे बेटा क्रिएट करूंगा मैं दूसरे अवेलेबिलिटी जोन में उसको फेच करने की कोशिश करूंगा. So this is what I'm trying to do in the today's class. Will be by doing so we can easily understand that EFS file system is shared between multiple instances. That's our whole purpose of doing the practical now, that we want to prove that this EFS file system, this is not only attached to the single instance or single availability zone, it is attached to the multiple availability zones and the multiple instances. Okay, so this is what we are trying to do. So step number 1, create EFS file system. Step number 2, create security group. Step number 3 will be create the instances. So let's do the same thing. So this is management console. I have logged in already. And oh, okay, this is a recently visited. Yesterday we visited EFS. Let's visit the EFS. Okay, before even we visit the EFS, I want to clear few of the data. So let's move to the EC2. If we have anything running and pending, let's move. Tags, limit,
Excuse me, sir.
instance. Yes, who's there? Yes,
अजीत
Ajit. Yes.
ये सर वो न्यू इंस्टेंस वगैरह या फिर न्यू टास्क परफॉर्म करने के लिए प्रीवियस टास्क को क्लियर करना वगैरह जरूरी है क्या?
Nahi beta, this is not necessary, but this is a good practice as we are using the free tier account. I have told you, free does not mean this is free for lifetime. Free means up to the certain extent we can use the services free of cost. After a point of, देखो बेटा, रात को 8 बजे अगर मैं इंस्टेंस को क्लोज नहीं करूंगा, वो रात के 8 बजे से लेके नेक्स्ट डे के शाम के 6 बजे तक वो इंस्टेंस या वो सर्विस, वो सिक्योरिटी ग्रुप, वो स्नैपशॉट, कुछ भी हम लोग क्रिएट करेंगे, दैट विल बी इन वर्किंग पेस. ओके, so I don't want anything to be working as I'm going to close the session. Next I'm going to create it for 2 hours, then I immediately going to delete it. By doing so, I'm trying to save the cost so that in the even in the worst scenarios we do not incur some of the cost in our AWS account. Okay, because this has already been happened to me. ऐसा हो चुका है सर्विसेज क्रिएट करके, when we forget it to close it, तो उसके बाद क्या है बेटा, फ्री टियर वाला जितना भी लिमिट है, यू थ्रेशोल्ड, यू क्रॉस दैट थ्रेशोल्ड, देन even for the free tier you will start having the billings. Okay, kabhi beta ek time pe, maybe in the next week starting, I'll try to explain you the cost and the billing dashboard. hum log wo discuss karenge, how you can set the reminders, how you can set the threshold values, all these things we'll discuss in the upcoming week. तो वो एक छोटा सा टॉपिक है, it hardly take 15-20 minutes for explanation, but it is extremely important in order to keep a track of the AWS account cost and the billing management. Okay, that will do. Before that, let's see. These are the few services. See, these are the few running services. I might have created this. Let's terminate these services. These are shutting down already. Instance type, launch, spot, savings plan, reserved instances. I have nothing. Dedicated hood, capacity reservations we have not used. AMIs, do we have created AMIs? No. Catalog, volumes, do we have a volumes with us? Yes, we have a volumes. Let's try to remove these volumes, but for that I need to have the instances to be stopped. So these are still shutting down. Let them shut down completely. It takes certain time. Failed to detach, unable to detach root volume from instance because it is still running, still shutting down. Okay, volumes. Then do we have a snapshot? No, we do not have any snapshot here. Okay, so snapshot security groups, we have multiple security groups. Let's try to delete this one. Okay, cannot be deleted. Elastic IPs, public IP. So this is still pending elastic IP. Okay, released, placement groups, key pairs, demo key pair. Okay, let's keep this one a demo key pair. Interfaces, network interfaces, nothing. Okay, So volumes are already gone because our instances have stopped already. So terminated. So this is gone. Okay. So let's move on. But the step number 2, as per this PPT, first of all, I need to move to EFS file system. So let's try to create the EFS file system. EFS, click on this file system. Very easy process. We have done twice yesterday's class. Again, customize. I'll be very quick in this. Let it be optional, regional, one zone, enable. You can enable and disable. And life cycle, here you will see you can move to infrequent access after 30 days time period, and termination out of this if on first ascents or none. You can select whether you want to move back the data from the infrequent access to the standard access. When it is first time it is going to be assessed, then, or you can click on none if you never want to change the from infrequent access to the standard access. But this is going to lose the data. I'm going to keep the on first access, general purpose, max IO, busting, enable encryption. So keep everything as it is. Then we'll move on to this one, and I need to have a security group. I need to create a security group because mounted, it is going to be mounted into 1A, 1B, and 1C. So we need to have a multiple availability zone, 1A, 1B, and 1C. So different are there, but before that, I need to again create a security group. So I'm going to open the another tab. So this will remain as it is. Click on right click, open the new tab, create a security group. Okay. Security group. Let's create a security group, and we are going to keep it as the number. Let it be ABC. You can give any name and let it be VPC. You need to have it. Keep it the default one, which is already there. No inbound rule not required as of now. All traffic from this done. So nothing is required to be changed here. So basic security group ABC security group I have created. Done. So you have no inbound rule in ABC security group, and no inbound permission, only one outbound. Let's move back to our this step. And okay, I need to refresh this because you'll not have ABC security group here. I need to refresh the page so that it moved back. Okay, chalo, koi baat nahi. So let's move and click on the next. So automatic subnet, it has chosen automatic. So as per the availability zone, automatically it has for the subnet. VPC is the default one. So I have only one VPC. Let's remove the existing security group and attach our own security group, which is ABC. This is ABC security group. This is ABC security group, and let it be ABC security group. So we have all the security group attached, and let's move to next. Optional file system. Let's click on next. Review and create. Nothing is required. Click on create, and file system is being created. It is still in the process. It will take certain time. This is done. This is done. This is created, and availability zone is regional, matlab all over the world. Multiple availability zones are falling under the regionals. Okay, so that is the given here. You can click on this file system. So this is the elastic file system with the ID that we have created. It has already provided us with a DNS name, and we'll be using this DNS name in a while, and it is going to use 6 KB. So everything is fine in this side. Let's move back to our place, and okay, management console, and we are supposed to now what is done. So we have created EFS file system is done, and for wrapping that we have created a securities. Now we are supposed to create the multiple instances. Okay, let's try to create the multiple instances. We're going to launch the instance and let it be an instance A. Applicability, let it be as it is, Amazon Linux 2, keep it as it is, instant ip2 micro, free tier. Key pair we need not to have, because why I don't need to have, because one of my instance will be communicated with the rest of my second instance, so key pair not required. So we can work this as it is. Security group, so it is going to create launch wizard 2 as a new security group, so I'll keep it as it is, nothing is required. Configure storage 8 GB of RAM, gp2, and file system. You cannot don't have a permission to for do this file system, EBS file system, but for that we need to have a, we need to select a subnet before we can add a file system. So let's move back under the network and setting, edit, click on edit and click on the subnet. Okay, let's choose a subnet. Now for A instance, I'm going to choose the AP South 1A. Okay, for instance A, I'm going to choose AP South 1A. So this is enable, launch wizard 2 is there, SSH anywhere, so everything is perfect. Network EBS volume, now you'll see we have got this EBS or FXX, so this is EBS volume. Add shared file system, and this is the availability zone is the original one, so this is the original one, and I'm going to copy this path. This is important, I'm going to paste it into the chat area. I'll need to have this. So everything rest of done. EFS, it is mounted in the elastic file system, and the first instance 1, it is mounted on mount point, we need to have this, and number of instances 1, everything is okay. Let's launch. Done. I need to have another instance. Let's launch one more instance. I'll have instance B. Everything remains same. Key pair not required. Edit. This time I'm going to select availability zone AP South 1B. Just for the demonstration purpose, we have chosen a different one. Create a new security group. No, I'll use the existing one. Launch wizard 2. But now recently we have created launch wizard 2. So this is the one. Okay, we have just created, I'm going to use the same security group. Okay, so then I have the file system. Let's click on edit, shared, automatically it has fetched it. So this we have copied it. Okay, and let's create the second one. Done. So beta, we have created 2 instances. Now this is done. We have created this also. We have created security group also. In 1A, we have created one instance A. For the another availability zone, we have created one. I'm not going to create the third one. Let's practice with the 2, because I just want to prove that if you create something here, store it here, it can be fetched from the different availability zone. That's the whole purpose. Okay, so we have got this, and let's refresh the one. So we have got, so instance state is equal to running, so we have got 2 running states. Okay, so this is there, and if I need to, I'm sorry, and if I need to move to the security groups, the security group that we have created, so this is ABC security group. Okay, 0 inbound permissions, inbound rules. So edit inbound rules. NFS custom. Okay, not anywhere from here. Just give me a second. We need to move to the launch wizard 2. Okay, so in launch wizard 2, IPv4 SSH TCP IP, this is 0, edit inbound rules. Security group is there, add a rule. Network file system. And I am going to have it here. So we need to find it ABC default my security group that we created yesterday. This is ABC security group. Let's have this. That means this is the security ID launch wizard, and this is going to have the, even if we are going to delete this SSH, let's remove this. Okay, so this is going to follow a network file system. Only one rule is there, which is going to take a traffic not from any IP address. It is going to further take a traffic from this security group that we have chosen here. So let's find once again ABC security group. Okay, save a rule. So this security group and a network file system TCP protocol is used. Port range, it is going to use the port 2049, and the source is going to be, instead of the any particular IP address, it is going to take from the security group. Okay, which security group? ABC security group that we have done. Now with this one you will understand better. This EFS file system, it is going to be bounded by the security group. But this security group is ABC, and for these instances I have used the launch wizard 2. Don't get confused. Security group created for these two instances, launch wizard 2, and this is the ABC. What I have written is, I have opened launch wizard security group. Inside that I have removed any of the IP addresses that if they want to communicate with the EFS file system, this ABC security group, but I have added this inside this. Okay, so the traffic is going to be monitored with the help of the security group instead of any particular uh, what we call IP address. Okay, then launch wizard 2. Inside this also, let's try to have inbound rule. NFS. Okay, so save the rules. Done. So this is done from our end, and now we'll move back to our instances. Setting is done, and better now I'm going to, how we are going to check if it is working fine. So I'm going to click on instance A and connect it using EC2 connect. Instance A, EC2 connect. Using instance A, I'm going to open the AMI console. So I'm going to connect this. Okay, so let's wait for it. Okay, we have removed SSH. We need to have the SSH. Without SSH, this might not work. Let's try to include security group, launch wizard 2. But why this is not working? Because we need to have a SSH inbound rule. So here one more rule is required. Add a rule, that is SSH custom anywhere 0.0, save rules. Done. And okay, so this is done. Let's move to our instances, and again I'll go to instance A, and let's connect this using EC2 connect. Click on connect. Okay, this is perfectly working. So better I have moved, this is for the instance A. If you can see this AMI for Amazon Linux 2 AMI that I've opened, this is for the instance A in one availability zone. So I'll move back, cancel, and let's try to open for the instance B. So this is the second instance which is also running. I'll try to connect second one also. And by the way, beta, if you need to see that both the instances are having different availability zone. This is one is in AP South 1A and the another one is AP South 1B. Both of them are in a different availability zone. So let's move to instance B, connected, instance connect. Okay, so B is also connected. So this is instance B, which is connected, and this is going to be instance A. So both of them are connected. So I'll try to write one of the script in instance A, then we'll try to assess that same commands using the instance B. Okay, so for that, there are the commands that we need to have. Give me a second. Okay, so first of all, I need to get the thing that I've copied in the comment section, the path, this one, EFS file system. Let's move to this the second instance. This is the instance 1A. So I'm going to write ls space /mnt/efs /fs1 slash. So that's the point. It is executed fine. And then let's try to write sudo for checking the content. So we have moved from EC2 to a root user, that is IP, that is my going to be root user. Now beta, I'm going to have here the command. Let's try to write echo. I'm going to do echo, and let's try to write the word that I want. It is hello world. Okay, this is hello world, and I want it to be written inside the file that is going to be control V. This is the path I have specified. This hello world, this is a text that I want to write inside this file, fs1 backslash, and the name of the file should be, let's suppose I'm going to write hello dot txt. So this is the name of the file, and within this file, beta, within this file, I'm going to write the content hello world. Okay, so if I'll do this, let's try to do. Okay, this is done. And now if you want to check it if it is running, let's try to add cat and then try to copy this entire path from here if it is displaying our answer. So I have written, and let's see if we are able to display this hello world or not. So okay, the moment beta I execute this command, तो उसने already मुझे को ये बता दिया कि hello.txt के अंदर what is present, hello world is present. So this is done. So that means inside my EFS file system, beta, now what basically I've done, inside this EFS file system, I have created one text file. The name of the file is going to be hello.txt, and inside that file I have written hello world. Okay, so this is done. So this is one of the, we have executed this command in instance 1A. So let's try to fetch the commands in the second instance. So this is 1A instance, this is the second instance. So I'll do ls, and let's specify the path here. Where is the screen? Let's copy this. This is the second instance. So fs1 backslash, so hello.txt. Better you'll observe I have simply did ls, list down the files, I have given the path. I have done nothing. I have created nothing. It has already given me that, okay, in ls, this file is already present. So you can see we have done nothing here. Okay. So after this, if we want to check what is written in this file, so we can do that as well. अब मुझे ये check करना कि ये जो file present है, what is written in this. I can still write cat and I can write this path cat copy paste, and then I need to write the file name. Then I'll be writing hello.txt. So I want to see what is present in this hello.txt. When you will do it, what you are going to be displayed? Hello world is being displayed. So now you can see the path. This is instance 2, which is available in the different availability zone. And I have created the file using the echo command using in different availability zone. But since I'm using the EFS, I'm going to use the elastic file system, which is a network file system. So that is why I am able to access. I don't understand. In 1A, I have created one of the file. It is stored in EFS. And then I have used this command in the second interface, and I am able to fetch the same file. But are you able to? Let's stop this. I'm going to exit. This is log out. Close this one. And let's do the exit from here. Log out. And let's move from here. Are you able to understand better the thing that we are trying that we were trying to execute in the yesterday's lectures? Are you able to understand this? How the elastic file system is going to provide with such a powerful feature that no matter in this entire world, wherever your instances are, if you are going to use this elastic file system, your multiple instances, hundred of instances can be connected to the EFS file system. Okay, so that's the point. Let's move to the EFS. Now we need to remove this. Let's click on the delete. This is the EFS file system. I'm going to copy this, delete, and it is deleting the mount target. It may take certain a while. So I'm going to instance, and let's have every instance deleted. Okay, terminate the instances. And the automatically volumes will also be terminated. So this is done. Okay, so elastic file successful. So we have nothing in here. So I'm going to close this tab. Are you able to understand this one? So let's move on to the another topic. So we have discussed this point is covered, and we have the some of the differences. If it is EBS and EFS, in EBS only in single availability zone you have the EBS storage. If you want to assess this EBS storage in different availability zone, what is the way? Better first of all create a snapshot, then from snapshot create a new volume. When you will create the new volume, then you can select the different availability zone. So this is the process by which you can copy the EBS volume. This is the traditional one. So then we have seen the different one just now, EBS versus EFS. This is just comparison is given. So using the EFS file system, multiple availability zone are connected to the single EFS file system. This is a mount target. Mount target, EFS mount target means the security group using which we are going to mount it. So this is done. Okay. Then we have the next topic is very interesting one, when very easy one is scalability and high availability. How we can scale whatever business. Suppose today if we have a one instance, tomorrow my business grows, how I can scale and how I can make sure that all the instances are working all the time. So this is what we are going to start now. Few theoretical concept, and then we'll execute this. Basically we are going to start. Here is the load balancer. Load balancing beta is topic ke andar we are going to start. Okay, so scalability means that an application or a system is anyone recording the session? Is anyone recording? Is Ritu present? No, she is not present. Okay, so let's start with another one, that is scalability and high availability. So scalability simple. First of all, we'll try to understand in a very layman language, and we'll try to take in one example to understand the concept of scalability and availability. Then we'll try to have a hands-on practice on this one. Okay, so scalability means that an application or an system can handle greater loads by adapting. Tomorrow if the business is going to expand, your the storage, your all the devices needs to be scaled accordingly. This may not be always in a positive context that business is going to grow. Even if you want to shut down and if you want to decrease the resources, you should be comfortably doing that. So there are two kinds of scalability. One is the vertical scalability, very important, and the second one is horizontal scalability, okay, which is also called as elasticity. So this is the important theoretical concept, that what do you mean by vertical scalability and what do you mean by horizontal scalability. In the next slide, we'll have the better understanding of these two terms. So scalability is linked but a different to high availability. Scalability and availability might look the similar. They are actually similar, but not exactly. So there is some differences between scalability and availability that we'll be understanding in this session. So now let's understand what is the vertical scalability and what's the horizontal scalability. But this is going to be the vertical scalability. This is going to be not because of the size. Now let's suppose, let's take an example. Beta, the example is, imagine you are having a company, and in that company you're having the 50 employees or 50 calls. You're having a call center basically, where you are going to receive the calls, and you are having a 5 people or 50 people are there. Now each person is capable of handling, let's suppose, 5 calls. Okay. Now if you want to scale it, how you can scale it? Better, you can provide this person, instead of 5 calls, if it is going to start taking 10 calls, the same person, you're going to overload it, or if you're going to overburden, if he's taking this 5 instead of 5 calls, if he's going to take 10 calls, that is going to be vertical scalability. Okay, this is going to be horizontal scalability, that you are not going to overload any single employee. Instead of that, you are going to replicate the employees, that if one is going to have a 55 calls, another one is also going to have 5 calls, the third one is also going to have 5 calls. So you're going to replicate the resources, which falls under the horizontal scalability. Okay, so we'll read the theoretical concepts, what it is written. So vertical scalability means increasing the size of the instance. Okay, when we are going to discuss with respect to the AWS. So vertical scalability, if you have a T2 micro, now understand the instance that we have been using. We have been using the T2 micro. Instead of T2 micro, if you are using T2 large or T2 extra large, this is what you are going to vertically scale the size of the instance. Okay, this is one way. For example, your application runs on a T2 micro. Scaling the application vertically means you are running out at a T2 large. So this is vertical scalability. You are actually going to scale the size of the instance. Now, the second one is vertical scalability is very common for a non-distributed system such as the database. So this is the use case where you can actually have this vertical scalability, which is a non-distributed. So that means everything is clustered into the single database, and you want to increase the storage in that database, you can go for the vertical scalability. Now RDS, elastic cache, and the services that can scale vertically. So these are the RDS. Better, this is also topic that we'll be covering. Elastic cache is also one of the topic that we're covering in the coming lectures. Okay, so these are the few services that can scale vertically. That means they can have the size increasing them. There's usually a limit to how much you can vertically scale. Now ऐसा तो नहीं है, T2 micro can be scaled to unlimited context. So there will always be an upper cap to this. T2 can be increased. T2 large, it may be T2 extra large. Let's suppose this is extra large, or it is 2 times extra large. So likewise, you'll have at certain foundation some limit up to which you can scale it, because it is a hardware limit. So there need to be a limit. This is what is vertical scalability. Coming on to the horizontal scalability, beta, in this, if one person is going to take 5 calls, I am not going to scale this person. I'm going to add a new person which can take 5 more calls. That means if you are going to use T2 micro, one instance, second instance T2 micro, third instance also T2 micro, fourth also T2 micro, that means you're going to have a multiple instances, but you're not going to increase the size. So that is your horizontal scalability. It is written horizontal scalability means increasing the number of instances system of your application. You're going to increase the number of instances rather than increasing the size of an instance. Okay, so horizontal scaling implies to the distributed system. So you can have this distributed. Now suppose 3 people are sitting in an India and they are making the calls. Okay, and this is a call center. These 3 people are sitting in an India and making the calls. Let's suppose these three people are sitting in the United States, let's suppose New York, and they're handling the calls from the New York. Now, what is benefit with this one? If it is a distributed system, that suppose tomorrow, if anything goes down in Indian office, if these three people are unable to work, still I will be having my another team that is going to be work perfectly fine, which is sitting in a New York. So that's a benefit of having the distributed system, and that's a benefit of having the horizontal scaling. This is very common for the web-based applications and the modern applications that use the distributed architecture, so they can use this distributed scaling. It's easy to horizontally scale thanks to the cloud offerings such as Amazon EC2. So very easily, now you might have understood how you can create an instance. You can get multiples, hundreds and thousands of instances within a fraction of second. So that's very easily created using Amazon EC2. Now, availability. So up to this point, the first 1-2 slides that we have discussed is basically the scalability. Now we are going to have it a differentiation with the terms of availability. Okay, how scalability and availability are going to be different from each other. Okay, so this is first building New York, second in San Francisco. The same example is being given. High availability usually goes hand in hand with the horizontal scaling. Okay, so I've got a message. Better, you have any question, Ajit?
Sir. No, sir.
Okay. So this is gone. Let's refresh this. Yes. ठीक है. Okay. So this is very easy to understand that high availability usually goes hand in hand with the horizontal scaling. Now, if you have 3 employees, then you have 6 employees, then you have 9 employees, then you'll have 100 employees, then you'll have 1,000 employees. Now, as the horizontal scaling is going to increase, better the high availability is going to come automatically, because availability will be directly proportional to the number of people working. So if you're going to increase the horizontally, so a high availability will also automatically be there. Now, high availability means running your application on system at least 2 data centers. So high availability means that it should be running on India as well, it should be running in New York as well. So minimum 2 locations should be given, so that we can call it as a high availability. Otherwise, if it is running in a single office, so we cannot claim it to be it is highly available. So we need to have at least 2 data center needs to be there, or basically we need to have at least 2 availability zones should be there, so on which the same application is running, then we can call it as it is highly available. So the goal is highly available to survive the data center loss. So why we want to have the data to be highly available? Because we want to survive the data center loss, that in case if something goes wrong, my other teams are working perfectly fine. So that is, we want to survive this loss. That's the sole reason. Now the high availability can be passive for this one, leave this. The high availability can be active, horizontally scaling, leave this also. We'll do this 2 points, we'll see when we'll be discussing practical now. Okay, let's move to the next one and see for EC2. Now, few important terms: vertical scaling, horizontal scaling, as well as the high availability. So few important terms are there. So in term of vertical scaling, you can increase the size of an instance, which can be called as either scale up or scale down. So you can move from T2 nano is the smallest instance, which provide you 0.5 GB of RAM and 1 vCPU of this processing. This is the smallest you can ever have, the smallest instance. And you can have all the way up to U12 TB 1 dot metal. This is the physical storage, which can provide you 12.3 terabytes of RAM and 448 virtual CPUs, vCPUs. So that's from, you can understand the power of AWS. From a very small instance to the final, the biggest one, you can get it. So this is the scaling. So instance can either scale up or it can scale down. Horizontal scaling increases the number of instances, which is called as scale out or scale in. When you're going to increase the number of instances, we call it as a scale out operation. If you increase from 2 to 4, then 4 to 8, then 8 to 16, that's a scale out operation. When you shrink the number of instances, we call it as a scale in operation. So auto scaling groups can be there, that can be performed. and there is a load balancer. That's very important. That's very important. Load balancer. Okay, we'll be discussing this point as well. What is a load balancer, how it can do it. Okay, the next one is high availability. This run instances for the same application across the multiple multiple availability zones. It can run the same in the application or the multiple instances. Auto scaling groups can be formed into multiple availability zones. Load balancers can also work in the multiple availability zones, so that is also available. So as I have told you, this is very important. So let's try to discuss the load balancing. So better read it once and try to figure it out yourself. What is happening in this slide? Let's take a feedback from you people. What do you think is happening in this slide? Better read this. What is load balancing? But what do you understand by the term dictionary meaning of load balancing? First of all, understand that, and then try to analyze the example that is being written here, and then we'll discuss. Is there anyone who can discuss something related to it? Better let's not limit this to the one-way communication. Please participate and tell me what do you understand by this load balancing. So there is something present here which is called as the ELB, elastic load balancer. There are few people made here. There are few instances made here. So what do you understand from this? But what do you understand from this? Please tell me. Yes. No answer, no participation. Beta, it is in front of you. Read this and try to tell me what do you understand? How big deal it is? No issues. But a load balancing means that there are multiple instances. Suppose this is one instance, this is one instance, this is one instance. Let's suppose there are 300 people. So this is 100 people, 100 people, and 100 people. So there are 300 people and there are three instances. So one way of communicating is these 200 requests are going to EC2 instance, 50 requests are going to this one, and 50 are going to this one. Is it balanced? No, because this is processing 200 requests, this is just processing 50. Or let's suppose this is processing 250 requests, this is processing 50 requests, total 300, and this is sitting idle. So that means if multiple requests are being made and you have multiple instances, now the load should be balanced equally. So if you have the 300 requests by these three people, so what should be the ideal scenario? That 100 requests should be managed by this, 100 requests should be managed by this, and 100 requests should be managed by this. So this is the simple work of load balancer. It is basically going to balance the load that is originating from the outer world. So this is the public area that is being, public is going to send the requests. Elastic load balancer is going to manage that request and it is going to forward it to the particular instances. Now directly this person cannot reach onto this EC2 instance because this will not be having the address like public IP or private IP address for this EC2 instance. Rather than that, but what they'll be having, all three of them will be having one IP address for this elastic load balancer. Okay, so all three are connected to only one IP, that is elastic load balancer, and these people are unaware. This person 1, 2, 3, but they do not know that their request is going to EC2 this instance or this instance or this instance. They are unaware. So this is a black box. They simply going to make a request to the elastic load balancer. Now this is the responsibility of this load balancer. This will be deciding that whether it needs to forward the request to EC2 this instance or this one or this one. Okay, so that's the purpose of elastic load balancer. So load balancers are servers. So these are basically the servers that are going to take the requests from the users and they forward the traffic to the multiple servers. Now these are the servers, elastic load balancer. This is also the servers and they forward it to the dedicated servers, like example EC2 instances. This is going to forward. So this is the simple work of elastic load balancer. Are you able to understand this? But are you able to understand this one? The very simple definition of load balancing. Outer public, they are unaware about the instances. There can be thousands of instances. Okay, now when I am going to Google anything, do I know that my request is being processed by which machine and it is present where? No, I am unaware, because I am just going to request to the one particular point, is that is this one. Okay, this is a load balancer, and further it is going to process the request. So that's the first point you need to understand. Why to use a load balancer? Better read this slide. Why we need to use the load balancer? Read it once. So we call it as a elastic load balancing. So why we can use this load balancer? It spread loads across multiple downstream instances. It spread the loads evenly, expose a single point access to the application. So now if my application, if I log into the facebook.com, everyone in the world will be logging into facebook.com. That is the DNS. We don't know how our query is being processed by which machine. So it exposes only a single point of access to the application, and it is called as the DNS. Okay. Now seamlessly handle the failures for the downstream instances of any of the instance. Now if I need to move back, but if any of the, now let's suppose if any of instances down, now this load balancer, beta, this will not forward the traffic to this instance, because this already know that this is not working fine. So what it is going to do is, if 300 requests are being made, beta, it is going to send 150 requests here and 150 requests are sent here. So this is the purpose of elastic load balancer. It can check and it can seamlessly handle the failures of downstream instances. So it can do it automatically. Do regular health checks of your instances. Now this elastic load balancer, this can do regular health check. How it is going to do health check? Beta, it is going to send a signal to this instance. Okay. And if this EC2 instance is going to reply, then this will came to know that this is perfectly working fine. Then elastic load balancer will send a signal to the second instance. Okay. And if it does not reply back, this EC2 instance does not reply back, elastic load balancer will come to know that there is a no reply from this instance. So that means I need not to send a traffic to this instance. Okay. So health checks are sent from elastic load balancer to EC2 instances regularly. So regularly elastic load balancer ELB is going to send health checks to the multiple instances. That is how it come to know that whether the instances are healthy or not, whether they are functional or not. So it can check in a that way. Okay, do regular health checks. So it provides a SSL termination HTTPS for your websites. Okay, so if you're using the HTTP or if you're using the HTTPS, it can identify very easily. So when the user is going to make a request, better elastic load balancer can differentiate here that the request is coming from HTTP or HTTPS. So based upon that, that can perform the distinction that, okay, if it is from HTTP, it will be processed by this instance, or okay, if it is coming from HTTPS, then this instance should process. So all the processing work is going to be done by this load balancing servers. Okay. Next is enforce strictness with the help of cookies, highly available across different zone. It can separate public traffic from the private traffic. So that's all the powerful ways in which the load balancing can work. Then coming on to the next one, why use an elastic load balancer? Okay, why we need to use the elastic load balancer? See, there are multiple types of load balancers that are provided by AWS. Okay, there are, I think, 3 to 4 different types of load balancers are provided to us by the AWS, and 1 or 2 of them are going to be discussed in this class. Okay, so we'll try to discuss them in this session. Now, the elastic load balancer is a managed load balancer. It is going to be automatically managed load balancer. AWS guaranteed that it will be working. So this is a very big statement, that AWS guarantees that no matter what, it is elastic load balancer will always be working. So it is providing us the guarantee. It takes the care of the upgrades, maintenance, high availability for all everything. AWS take care, provides very few configuration knobs. So if you want to fine tune the load balancer as per your requirement, so it provides some of the configuration knobs. Other than that, majority of the work is done by the AWS. That's the power of the AWS. Now it costs less to set up your own load balancer, but it will be a lot more effort at your end. Okay, so if you want to have your own load balancer server established at the offsite or physically into your offices, you can do that as well. It might not cost you that much, but it will be a lot more effort at your end to maintain it, to segregate the data, which instance should process which data, and how everything should be working. So it's a very big, the more effort is required. So it is integrated by many AWS offering. This elastic load balancer ELB is already integrated with many the services, like elastic load balancer can work with EC2 instance, it can work with EC2 auto scaling, it can work with the scaling groups, Amazon ECS. By the way, ECS is very interesting topic that we'll be discussing. AWS Certificate Manager, CloudWatch, and all these services are already integrated with the Elastic Load Balancer. Okay, so you can simply use the Elastic Load Balancer without establishing a the without worrying about that how these applications are going to work, because at the back end this is already mapped. Elastic Load Balancer is mapped with these services. Okay, now let's move and see health checks. Now, if you remember, I have told you that it is going to perform the health check. So this is, it provides the regular health check. Now, health checks, how these are provided? So it is written here. Read it once. But I'm really sorry for the error in the network. Please tell me, I was speaking alone. Please tell me what was the last thing that you have read. But what was the last thing where the network went on? I really have no idea. कौन सी last चीज थी जो हमने पढ़ी? Am I audible to you? Can you please tell me yes or no? But this is absolutely not acceptable. You are not even telling whether I'm audible or not. How this is going to work? Am I audible? But I'm going to have a attendance. I need
Yes, sir, you are audible.
not like this. Not like this. Ajit Kumar, are you present? I'm going to remove the everyone, those who are going to not respond. Ajit Kumar. Ajit, are you present in the session? No. See your attentiveness. Aryan. Aryan, are you present? But no issues. See, you find it funny or you may find it very casual. Keep this thing in mind. I have the complete authority. I have told you yesterday as well as your attendance, evaluations, recommendations. So please make sure don't take this training very lightly. Okay. So I do not see not even a single person participating in this entire the discussions that we are going to have. If I'll ask you if I'm audible or not, still you people are not capable enough or to respond that yes sir you're audible or we are listening or we have any doubt. So no response from your side. This is absolutely not acceptable. No issues. But I'll drop a text message after
You
this.
are audible, sir.
Yes, I am audible. I know. Even if I'll not be audible, but everyone will be participating. I know how I need to get things working. So doesn't matter. I'll conclude this session and we'll see from next class onwards. Either none of you will be joining in the next class or all of you will be joining with all your videos will be starting. So let's make this very clear. Or you can skip this training and I'll drop a mail to the university that I am not going to teach these students. From tomorrow onwards, everyone needs to turn on their videos because a lot of students are just switch on their stations and they're just not present in the class. So this is not a way to learn something. So let me share the entire screen once again. So better we have been discussing the different type of load balancers. So we have a classic load balancer, which is called as a V1, which is a older generation and which is outdated or which is the deprecated. Okay. So we do not, it is not recommended that we should use this one. Okay. So this is the outdated or the deprecated one. It uses the protocol HTTP, HTTPS, TCP and SSL. These are the protocols used. Then we have the second one is the application load balancer, which is of the newer generation. From 2016 it came into existence. Third one is a network load balancer and the fourth one is a gateway. And by the way, this is beyond the scope of the syllabus. Will not be touching the fourth one and will be discussing all three. Okay. And you can have it is recommended that we should use the newer generation load balancer. That means we should not use this classic load balancer and we should use the newer generation like application load balancer. We should prefer using this one. And we can have the load balancer that can be set as internal for within the network, within AWS, or we can set at the load balancer, which is for the external public, that like DNS. Okay, DNS is your external ELP. Then we'll have the next one, load balancer security groups, that how the security groups are going to be allowed. So any user is going to send the request from HTTPS or HTTP from anywhere around the world. It will go to the ELB, Elastic Load Balancer. It is going to filter out and send the request to the EC2 instance. Now, EC2 instance, these are the servers which is going to process the things, will send back to the load balancer, and the result will be displayed to users. So this is how it is going to work. Then we have the classic load balancers. Okay. Now, classic load balancers, what is going to have is this is a client. Client is going to send a request to the CLB, classic load balancer. and this is going to be the public client present in the public platform, and internally this request will be sent to the EC2, and EC2 is going to respond back to the client, and you are going to have a fixed host name. In this case, we'll see in a couple of minutes in the practical that how you're going to have xxx.region.elb amazon aws.com. Rest everything will same, so this thing is going to be changed. So beta, when I'll say this classic load balancer, this is outdated or this is deprecated, that does not mean it is not working. Okay, so AWS does not want this, discourages the use of the classic one because this does not provide the better functionality and the features, but still this is operational. Okay, this is all 4 are operational. We'll try to first of all start with the classic load balancer, then we'll try to move on to the application load balancer. Okay, so this is all for our theory, and now we'll start with the classic load balancer, the practical one. Okay. Okay, so we'll go to our management console, and the very first thing when we'll go to the management console is we need to go to the ELB, Elastic Store. Okay, so first of all, we need to create the instance, and I need to have the commands. I'll be running the user script. Okay. So all these are terminated. Let's create one instance. I'll be running the, let it have the new instance, and but I need to run the user data script because I want my server to be here. So application, this is done. 60 instance type T2 micro, and we'll have the key pair, let it be demo key pair, and VPC, create a new security group, launch wizard 3. I'm going to have it everything set, file system, advanced details, and move to the user data. Okay, so I need to enter the user data. I'll move on to the code, EC2 fundamentals, user data, and this is the entire code. Copy, and this is basically I'm going to launch a server on one of my instance. That is going to be name is going to be new instance. Okay, so let's launch this. Now this instance is being launched. Now this instance is being launched. Now I'm going to go to the load balancer. Let's see if we have new instance. This is pending. This will launch. In the meanwhile, beta, move to the this pair. You'll see the load balancing, and under this you'll have the load balancers. So click on the load balancers. So we'll click on the load balancer. You'll see you'll have no load balancer here. Okay, so we'll need to click on the create a load balancer. You click it here, and you'll have the 4 options. Okay, you'll see beta, these are the okay, load balancer type. Select a load balancer type. Now this is very easily written. The diagram starter being the load balancer in application. This is the user send the data. It sends to the HTTPS, and it is going to one of these instances. Okay, so there are multiple type of instances. Lambda function is there. EC2 instance is there. So network load balancer, gateway load balancer. So different type of there. But we are focused on this one, the underneath, that is a classic load balancer. We are going to start with this one, even though it is written previous generation, and we are going to click on this classic load balancer. Okay, so classic load balancer. So AWL will be retiring the EC2 classic node on August 15, 2022. So this will be retired very soon, but this is important to understand. So this is the user, this is the classic load balancer, multiple you can say load balancings is given from HTTP, HTTPS, TCP, SSL, and these are further connected to a lot of instances. Now they need to send the request. It will be going to the load balancer, and it is further going to send this to the multiple clients. Okay, multiple EC2 instances. So we are going to click on the the previous generation one, the classic load balancer. Let's click on create. Okay. Now, when you click on create, but you'll see some interface is going to open like this, and I need to give the name to this one. So let's try to give it a name. I'll give it a name as it will be my demo classic load balancer. Let it be my demo CLB, and let's keep everything for create an internal load balancer. Now I have told you can have the internal as well as the external. If you'll see here, okay, so if you see here, you can have the internal one or external one. So that option is also present here. You can select if you want to create as an internal, but I don't want it to be used internal because I'll be accessing it from one of the computer which is outside, and so I'll be not selecting this. Enable advanced VPC configuration, leave it as it is, and the listener configuration is mentioned. Okay, now listener configuration is this one. So how the load balancer is going to listen, it is present. So if the traffic is coming from HTTP and it is landing onto the port number 80 of the load balancer, it is going to receive at port number 80, and it is going to send HTTP to the port number 80 of the instance. Okay, so this is how the listener configuration is going to be written, and you can add the, of course, you can add the configurations if you want. So this is important, originating from HTTP, landing onto the port number 80 of the load balancer, and it is further going to redirect HTTP to the port number 80 of the instance. Okay, and you need to, the second one is, I'll click on assign a security group. Now there are multiple security groups present here, so you can choose the any security group. So either you can create the new one or you can create the new security group. Let's write it. I'm going to create the new. Yes.
So please explain internal and external load balancer once again.
Okay. Better the load balancer. Let's suppose if I'll have a box. Let's suppose यहाँ से explain कर देते हैं. Okay. Now this is, let's suppose this is one of the instance. This is the load balancer, and there is one more instance that is present here. So multiple instances are there. All the instances are connected to the load balancer. Now, if this EC2 instance wants to communicate with another EC2 instance, if thousands of EC2 instances are present, they will be communicating using the load balancer. Now, this is EC2 1, send a signal to the load balancer, and this load balancer is going to send the signal further to different EC2 instance. Okay, so that will be our internal load balancer. But if the load balancer is going to receive the signals or the request from the external user from different IP addresses present publicly, then it will be called as the external load balancer. Okay, so load balancer can be used in the two way. Either it can be kept internally for usage between the different EC2 instances, but for that case, no user will be able to access the load balancer because it will be having only private IP address which will be shared with the EC2 instances. Now here, the load balancer will have the public IP addresses, and which will be encoded into DNS, which will be shared with the user, so user can use this public load balancer. Okay, I hope you are able to understand this.
Sir, if any instant is coming from one IAM to another IAM, that will be external or internal?
Beta, one IAM user, that will be, of course, external. Beta, if you have the different IPC, don't consider the users to be the one. You need to consider the IP addresses. The answer will remain same. If the IP address is the private one, and if it is shared between the load balancer, it will be the private one. Okay, but if you are going to use the public IP address from IAM user, so IAM user can have both the public and the private one. You might have seen when we have created a user, if whenever you're going to create an instance, you have the public address also, private address also. If it is accessible using the private address, then it is a private load balancing. But if you need to use the public IP address for accessing it, it will be your the public load balancing. Okay. So we need to create the, let's create a new security group. So I'm going to select it. Let's me write my first load balancer. This is going to be SG security. Okay, so you can give any name basically. So I have given this one description. Let's leave it as it is. So load balancer, this security is going to have the default one, customer TCP IP is there. So TCP protocol is going to be used, which is at layer number 7. Port will be used for 80, and source will be anywhere the traffic is originating. So I'm going to use the default one, and then we are going to click on the next feature, that is going to be configure security setting. So let's click on improve your load balancer. Okay, why this is giving us this warning? Because we have not used the secured one. So neither we have used beta HTTPS, ना तो हमने ये use किए हुए, neither we have used secured socket shell, neither we have used this one. So this will not be secured. तो उसी का ये warning है that whatever I'm trying to create load balancer, there's a security warning is there. I'm not using the secured one, but that's okay. This is what the practice. I'll be using configure health. So configure health check. This is important one as we were checking here. So health check is important. Now let's try to understand how the health check is going to be there. So health check ping protocol HTTP will be used on what port 80, and this is using the /index.html. Response timeout. If the instance is not going to respond within 5 seconds, so this will be considered as that the health check has failed. Interval will be after how much interval you will be checking this health. Okay, so after every 30 seconds, if you need to check the health, so in that case, so you'll be having 30, or you can have it after every 4 seconds. Unhealthy threshold, that means if consecutively 2 health checks are going to fail. Unhealthy threshold matlab if consecutively 2 threshold in consecutively 2 health checks are going to fail, it is going to declare it as an unhealthy instance. Healthy threshold matlab if consecutively 10 health checks are passed, I am going to consider that it is going to be healthy. Now you can, okay, response interval, health check interval must be greater than between 5 to 300. Okay, let it be 6, 7. So this is what is present. Okay, now this is very important, this index.html, this is important to understand, and but for that we need to move to what is this ping path. For that I'll go to EC2 to explain what is this ping path, and let's see our instance. And by the way, do you remember the instance that I've just launched and new instance, but I have written the user script into this. So that means the server is already installed it. I'm going to copy this public IP address and I'm going to paste it in the new tab. Let's write HTTP. And this should be good too. Not working. Can anyone tell me what could be the issue? Better, there are only 2 possible ways if you are not able to launch the server. One is the user data script that I've written. If it is not proper, then you can get this error. Or if you have the security issues, then you can have the error. So let's move to the security and see if we have both the protocols. Security group launch wizard 3. Let's go to this security group. Add rule HTTP. I'm going to include HTTP. Where is HTTP? Okay, include this from port number 888 custom, anywhere from IPv4. This is done. Okay, now if we'll move back to our EC2 instances, and I'm going to go to details, copy the public IP address once again and paste it, include HTTP. It should work now. See, it is working. So hello world, I'm getting from IP. This is going to be my private IP address, and I am accessing it from my public IP address. You can see it is. I'm going to reload. Again and again. I'm going to click on refresh button. You will see the page is loading every time from here. You can see. Okay. Now ping path is here. Why I have done this? Now you will move to the instance, and you will see ping path. Now if I'll copy this index.html, better this is still going to work, and if I do this, then I'll write the index.html here. So see, even if I'm going to do index, I've written index.html, still it is going to be loaded perfectly fine. So this is going to work. Or the second way is, if not index.html, you can simply, if you're going to write it, if you're going to remove this, simple अगर आप \p बेटा लिख देते हो, even then it will work. You can see, even with the help of \, still it is going to work. Okay, so this is the ping command. Or if you will do randomly anything, like if I'll write do this, and if I'll write like this, कुछ भी लिख दो, if you are going to do this, you will not found. That means URL not found. It is not able to access that one. Okay, so that's the ping command you need to include, and I hope you are able to understand this one. So this is working fine. So that's a ping you need to include anything, and we have index.html. This is working fine. Okay, now let's move back to our okay, so this is healthy. Let's set v3. So we have done everything is good. Now next, add EC2 instance. Now I need to add the EC2 instance to this. Now let's click on add this. Now since I have only one instance that is running with the name new instance, and already beta this new instance is running, and we have a user data script in this that is working, and I'm going to add this instance here, one instance, and availability zone is the distribution instance AP South 1B. So this is in the zone AP South 1B. And then you can, if you want to do, you can add the tags. Okay, then create add tags. So nothing required, review and create. So define load balancer, everything is written. So load balancer, my demo CLB scheme, port 80, forwarding to 80 HTTP, page, index.html, timeout, interval, healthy, unhealthy, EC2 instance, enable, instance ID, VPC, subnet, security group, my first load balancer. So everything is there that I've done. So create. Okay. So we have successfully created our load balancer. So we have, let's close this. So this is our first elastic load balancer. You will see here all the details. So basic description name. Now you'll see it as a demo one. Beta, this is the load balancer. Now this one, this instance, we are assessing it from the private public IP address. So this is the directly any user with this public IP address will be able to access it. But now if I'll go to this one, and if I'll have this my demo, if I'll paste it, and you'll be able to should work. So my AP South 1 ELB Amazon AWS.com. So this will remain same. If you have seen this, I have told you that the region name .elb.amazon aws.com. So this will remain same. Region name is AP South 1 elb.amazon.aws.com. This will remain same. Okay. Now why you are getting this error? Because this is now instant, this is in service. So sometime beta you get a out of service error here. That's why this might not work. And let's copy this once again. See, beta, we have just copied, and this is from the my demo CLB AP South 1 ELB Elastic Load Balancer AWS.com. So I'm getting the same instance. I'm running the same server script, and I'm same getting the IP address. This is the private one, and I'm assessing it through the load balancer. Now this particular one in the next tab, this is the same answer that we are getting through the IP address, and this one I'm assessing it through the elastic load balancer. Okay, so this is done. Are you able to understand this one?
Yes, sir.
Okay. Now I'll show you one more thing, important thing. If I'll have the multiple instances, okay. So let's try to create the another instances. Instance. Let's try to create one more instance. Launch instance. I'll have it as a new instance 2. Let's keep everything here. Demo key pair. Launch wizard. Which one we have used? 3. Launch wizard 3. Security group. Add advanced details. User data. Copy the script for the server, and let's write it here. Launch instance. Done. Let's try to have one more instance. New instance 3. Okay. Keeper. Demo key pair. Create as existing one security group. Launch wizard 3. Configure advanced. Move down and paste the user data and launch. Okay, now we have launched 2 more instances, and let's refresh this one. And let me search for the instance state. Should be equal to a running, and that should be displayed only. So let's have all 3 states. Okay, all 3 states are running. So these are 2 initializing. So let's go to the, now I want, see bit of one instance which is already running, new instance. This is already the part of load balancer, but I have created new 2 instances. So I'm going to go to the load balancer. I want to include these 2. So this is load balancer. Go to the instances, and in edit instances, you will find it. But one new instance is already the part here, and I want to just have the edit instance. Click on edit instance. So new instance 2 and 3, you will find it. Add this also, add this also. Okay, so you'll add the another one. So you can have all the instances you can add. Okay, so these instances are all in the same. Okay, let it be save. So you will find it, but this is out of service. Now if you'll do for this one DNS, this might take certain time. Okay, so let's wait and move to our management. Okay, so all three are in service. Okay, so all three instances are instance 1, 2 and 3. All threes are in service and all threes are associated with the load balancer. Now if I'll go to beta this from the DNS that I've copied, and if I'll refresh this, you will observe that every time, see, observe, load, what is load balancer is going to do, beta every time I am going to request, it is going to send my request to different instance out of new instance 1 and new instance 2. Every time my request is going to be going to different instance. That is why every time when I'll click on refresh, I'm constantly refreshing it. You will observe every time private IP address is changing. So first click I'll do, this is different instance and this is the private IP of different instance. Again when I'll click this, next time now my request load balancer has sent my request to a different ID, so I'm giving this different one. Third time again I'll do the refresh. This time my request is going to the different load balancer and I have got the different answer. So you might have understood this, that there are different in these instances that I've created, 1, 2, 3. Every instance of, it's better if I can show you to the instances. So better, this is new instance. It is going to have a the private IP with 148. Then this new instance B private IP. Oops, let it me. Okay, then new instance 2 with a private IP 166, and if you'll have the new instance 3, which is going to have private IP 93. So there's a 3 different instances, and every time you click on this one, so you will be having the response from the different instances. So every time load balancer is, this means absolutely my load balancer is working fine. Okay, so because I'm assessing it from the DNS server, so because I am if I need to explain it to you, so that means elastic load balancer is working fine. This is new instance 2, new instance 3. Now I am assessing from here, so my first time it request goes to this instance, second time goes to this, third time goes to this. Every time private IP address for this instance is displayed, private IP address of this instance is displayed, and the private IP of this instance is displayed. Now my elastic load balancer, beta, as a user, I do not have a control that which instance ID I want to display. Okay, so if this is the case, when I'm going to refresh, but I do not know which is going to be the next instance where my request is going to. I can simply press this, and every time a new instance is going to be receiving my request and responding accordingly. Are you able to understand this point? But this was the only thing that was required to be understood in case of the classic IP. Okay, so sorry, classic load balancer. Then we need to discuss the application load balancer, which is having tons of the features upon the classic load balancer. हम लोग क्या कर सकते हैं बेटा? I can give you just an idea. What we can do is, I can say that if I can write the condition that if load is coming from HTTP, it should always go to this instance. And if the load is coming, let's suppose in HTTP, if something has written as constant, I want to display the error message on the screen. Or if any other request is coming, I want it to send to the different instance. So this customization that I'm basically talking about, the application load balancer ALB that is going to handle it. Okay, and tomorrow's lecture will be starting with our the what we call this application load balancer. You will see here the classic one, then we'll have the application load balancer, and this is our next topic. Okay, so we'll see the last application load balancer. So if you have okay, let's delete everything. I'm going to delete everything, but if you have any doubt, you can ask me. If you have any doubt, this is the end of our session. Don't leave. Let me take an attendance first. Beta, nobody should leave. Instances are down. AMI. Volumes. Okay, these are default one, automatically deleted. Snapshots, no. Security group, let it be. Elastic placement groups, no. One demo key pair, network interfaces, this will be default one. Load balancer, so I am going to beta action. I'm going to delete this load balancer, the classic load balancer. Yes, delete this. So load balancer is gone. Okay, so no instance found. Running is done. Okay, so every instance is terminated. Now only 3 instances and all 3 are terminated. So let's sign out from here. Close this, everything. Okay, and let me stop the screen share. But don't leave, don't leave. The students are leaving the session. Better attendance. Let me take the attendance. Who has left? There are only 15 students. Rohit Kumar also left. Okay, done. So this is all for our today's session, beta. So thank